might have wondered before, what is cross-site request forgery, or what is server-side request forgery? And what's the difference between the two of them? Well, we're going to answer those questions and more in this video. Stick around to find out what they are, the difference between the two of them, and to see them in action in a demo. Now, in order for us to understand cross-site request forgery and server-side request forgery, I want to illustrate that for you, but instead of doing it digitally, I'm going to use a whiteboard. So I'm going to grab this whiteboard. The only whiteboard I had is my kid's whiteboard, and this was apparently Cupcake and Roger. So we'll use those personas to understand cross-site request forgery first. So we'll have Roger as the attacker. Okay, Roger's over here, and we are going to have Cupcake, which is the user, over here. Now, Cupcake goes to their bank, bank.com, via the browser, and they make the normal actions, back and forth, sending requests from the browser. This is the browser level. It's happening in the browser, and then you have the server level. Can you read my writing? Kind of. And when Cupcake's using their bank.com account, they expect things to happen. They're doing these actions intentionally. What the attacker, Roger, can do, though, is if they know that this as a CSRF, cross-site request forgery vulnerability, vuln, they will then craft on their own website, let's say attack.com, a way to send that request to that server without the server knowing that it's actually coming from attack.com. So what does that mean? Well, it means that what Roger will do is they'll set up their website to make requests to this server, but on behalf of other users. And the way they do that is by tricking Cupcake, maybe through an email or through a text message, to get them to click on a link that brings them to attack.com, but they're logged into bank.com already. And what attack.com does is it sends the request as Cupcake to the server, and the server has no way of knowing that because the browser is dumb. The browser's like, oh, I have cookies for bank.com that I'm supposed to use, so I will send that cookie as part of the request to the server, whether it's coming from the website by bank.com or not. So that's what Roger will do to trick Cupcake into making requests for a particular website that they're authenticated with without them intending to do those actions. So it could be something like transfer money from one bank account to another bank account. That's the typical example you'll read about when you're learning about cross-site request forgery. All right, so for server-side request forgery, it's slightly different, but it's the same kind of concept. It's just happening in a different space within the overall architecture of a system. So we have the browser again, the browser level. I think, in this case, Roger is not going to really set up attack.com. They could potentially do that, but for server-side request forgery, we're not dealing with that, okay? And what's going to happen instead is Roger's really going to be going to, let's say, bank.com directly, okay? And bank.com, the way its architecture is set up is similar to what we said before, right? It has the main server that's being used for different actions and requests, but Roger becomes privy to the fact that server actually depends on another API that it's sending requests behind the scenes. And that gets exposed in different ways, which we can get into the weeds of that, but it can be pretty obvious when you just look at the developer tools in your browser to understand how requests are happening. Or a lot of times server like websites will just let you know that they get their data from somewhere else or something like that. Or again, it's just they don't really hide the fact that they're making internal requests because the responses that come back will sometimes include this information. There's a lot of different ways attackers will become aware of internal APIs or other services that the main server that's hosting the website is relying on. So what Roger will do in a server-side request forgery is they will trick the server now. Instead of the browser, which was cross-site request forgery, we're now tricking the main server that's for that website to make a request to the API that it's not intended to do. Like, so that Roger can get more data back from the API, Roger can get more sensitive information about other users, whatever it may be. They try to exploit the fact that this server is making additional requests that it wasn't designed to actually make, even though it's leaving that door open for Roger to do it. So the difference, if you're picking up on what I'm putting down here, between cross-site request forgery and server-side request forgery is CSRF is happening more so in the browser and directly to the main server, whereas server-side request forgery is happening behind the scenes on the back end from one server to the other, whether it's an API or this could be some other service. And that is cross-site request forgery and server-side request forgery and the difference between those two. Next up, what we're going to do is we're going to see them in action with the live demo. All right, so let's first get started with a cross-site request forgery demo, or CSRF demo, which you can see here in my project structure for this video. In it, I built out a very contrived demo that's going to be a bank application that allows a user to log in and then transfer funds from one account to the other. So imagine we now have this open and we are going to log in. This is the bank application. We have the login. I am going to sign in as user 1 with a password 1 password. And now I'm logged in. Now, one of the key things to note here with cross-site request forgery is an authentication mechanism that's storing a session via cookies. Cookies are tried and true way of transferring data from the server and storing it into the browser, and then the browser also sending that back with subsequent requests. And that's how we can keep track of the authenticated state that user 1 is logged in for this web application. And as a result of that first login request, if we look at the headers returned, we could see that the server told the browser, set this cookie that's the name of session with the value of user 1. Now, should you do it exactly like this? No, this is just a demo, but is a typical way that authentication is handled and stored. The state of authentication is handled and stored. And what that results in, as you saw before, we go into the cookies here, is we now have a cookie named session with user 1. Now keep that in the back of your mind as we go through the rest of this. Moving on. If user 1 wants to transfer to, let's say, user 2 some money to them, they have a balance of 1,000 whatever credits in this case, and we're going to say that we want to transfer, I don't know, 50 to user 2. When I do that, the transfer was successful, and now the balance shows 950. So that is this bank application. Now, when it comes to cross-site request forgery, if we look at the request when we did the transfer request, you'll notice that as part of the request, the browser will automatically include the cookies that are stored browser side for this domain, in this case, localhost 3000. So when I send the request via JavaScript to execute this transfer, the browser's handling that for me. It's just blindly kind of doing that because it's like, okay, this is localhost 3000 and the request is going towards that domain, that server. So I need to find any cookies associated with that, which is this one. If we look at domain is localhost. So then it goes and grabs that cookie and sends it as part of any request to that domain. Why is that a big deal? That's where cross-site request forgery can come into play. What an attacker can do now is they can, from their own website, let's say their domain, they can contrive a request behind the scenes, whether JavaScript or via a form, a hidden form, and cause a user to perform an action against the original domain, localhost 3000 in this case. So if we go back to the code, I'm going to show you the attacker example. So in this case, I have the attacker under a malicious HTML page, and in it is this form that is not displayed at all based on this style. And it's going to send an action, a post request to localhost 3000 transfer, which is the API that's being used to transfer money. So imagine the attacker is user 2. Let's say that's their account with that bank that we were talking about before. And what they want to do is they want to trick user 1 into transferring money to their account. They can do this via this cross-site request forgery vulnerability. Just focus on this right here, okay? So this I'm running separately under a separate domain of localhost port 3001. So if we go back to the browser and I go and open up localhost 3001, we can see it's just a file server basically for us. So when I actually click on and open up the malicious HTML, let's take a look in the network tab what happens here. We get a response of success true and the transfer was successful. If we look at the actual request, we can see it was to localhost 3000 and the transfer API, and as part of it, the browser was kind of dumb. It sent the cookie with a value of user 1. Now you might be thinking, how does that happen or whatever? In many cases, it could be through an email, a phishing email, where you can get that user, the attacker targets user 1 and gets them to click on a link that brings them to their own URL, some URL that has the cross-site request forgery payload set up ahead of time that will execute this unbeknownst to user 1. So imagine them just accidentally clicking on a link or intentionally clicking on a link that they were tricked into doing. And this happens behind the scenes without their true intention from wanting them to do that for user 1. Now, if we go back over here and we check the balance again, we could see it dropped by 850 because of that transfer that happened earlier which if we look at the payload that was sent, it was to user 2 and the amount of 100. And this should not be possible. This should not happen. This is capable because of a cross-site request vulnerability in the demo application that I built here. All right, so that was our demo on cross-site request forgery in action, exploiting that vulnerability in the demo. You might be wondering, how do you protect yourself from this attack and this vulnerability and mitigate this risk? Well, we have a blog post for you that you can check out on the snyk.io blog post. That's snyk.io. Link will be in the description below, where you can read more on how to protect yourself and your apps against cross-site request forgery. Now that we finished cross-site request forgery, CSRF, let's check out server-side request forgery. And for that, we're gonna take a look at the code, this demo first, and understand the code a bit more. So we're starting off with this demo for server-side request forgery, and admittedly, it's a contrived example to get the point across, but we need to understand the scenario where server-side request forgery is made possible, and that is when your API makes external calls to other APIs behind the scenes. Your server is making calls to another server to get more data or more information to help create this rich feature in your app or whatever it may be. And I'll have more real world examples to share with you actually that happened fairly recently once we get through this demo. So in this case, in my demo, I have it where you can send a post request to SSRF, of course, and in it, the user is able to pass in a URL which we use to send a request out based on the URL that's provided to us. Again, not typically what you would allow to do, but this is, again, for demonstration purposes. So what's happening here is the user is able to influence the call, that external call that goes out from the server side. So you might be thinking that, oh, this is server-side code and I have control over this. But when you're leveraging user input as part of that request, that's where server-side request forgery comes into play. So different from CSRF, where it's happening more client-side, this is happening server-side, from server to server. So in this case, I allow the user to send a URL parameter here. So let's try that out. So I'm using an extension called RESTbook in Visual Studio Code, or in this case in Cursor AI, and I can just pass in this. And when I send that to the server, we can see it sends a response of, you know, I'm retrieving the Snyk.io website, and I can see the contents of it here. So you're thinking like, there's no way I'm gonna let a user give me the full URL, or any URL for that matter, for my application to send requests to other external services. But there are actual real world scenarios where this has happened even recently. Let me show you. So there's a fellow YouTuber that does a lot of awesome dev content called Dev Cody. Go check him out if you haven't done so already. He has some great content on there. He was very vulnerable and shared that this is why, one, he used AI to help write this code that he has for his application that he's building. And in it, you can see very clearly that this URL, where he's making an external request on his server side for this application, has some inputs that are provided to it to generate the URL, right? So in this case, there's a convex ID, project ID that gets passed into the first placeholder, and then storage ID in here. And what ends up happening is the user on the client side can actually provide the value for this particular parameter here. And so what he found was somebody was able to hack his side project that he was working on, and they thankfully responsibly alerted him to this. And then he was nice enough to share that experience so that others can learn from it. So this is a real world example of a server-side request forgery happening in an application that a fellow dev YouTuber created. So shout out to Cody for sharing that and helping other people learn from it as well. All right, that said, how do you prevent this from happening? Well, the plain answer is don't allow users to influence or have input into your external calls for other services that you rely on. But on top of that, you want to do more input validation and sanitization. Anything that comes in from the user or from a client-side application into your server, you need to ensure it is up to your expectations. But further to that, we have a blog post on this as well about preventing server-side request forgery in Node.js applications, but the practices here can be applied to other programming languages and ecosystems. So link to that will also be in the description below. All right, that does it for this video, and I hope you got value out of it. If you did, be sure to like it down below and share it with somebody who can put it to use. And if you made it this far, subscribe to the channel so you don't miss out on upcoming videos. Thanks for watching, and happy, safe coding, everyone.